Good morning, San Diego. So as Heather stated, we actually took on a very ambitious project in order to build everything in containers and build an entire 5G network from the radio to the core components. And we started off this project with partnership from different vendors as well as open source communities. And first it was OAI who signed up and said, okay, let's build this as a live network in France. So that's what you see as a Eurocom facility in Sophie Antipolis in France, where they actually have live radio deployment and a core deployment. Then we built a POP in Montreal with the help of one of our partners, Lenovo, to actually build the entire infrastructure and run a core over there. And with that, we said, well, how interesting would it be if we were to actually bring an entire POP right on the stage here with us that is remotely connected to the core in Montreal. So that's what you see here at the back is the full edge POP with some servers that do edge compute, that do the radio capability with a Faraday cage that was custom built just for this particular demo, and a 5G radio in there. So I'll walk you through those in a moment. Let's go look a little bit deeper into what each one of these setups are. So the first one is the San Diego POP, and what you see in the San Diego POP is essentially a 5G phone that's connected to two different radios, the LTE radio as well as the 5G radio, and then you have a piece of software that's running on a whole bunch of servers that you see in that POP. That software is essentially the radio software, CU and DU. That software is also firewall, that's all running in containers. It's also an SD-WAN gateway. The firewall is from our partner A10, and the SD-WAN gateway is from our partner Turnium. And we have actually an interesting software-defined fabric that's also part of this same setup, and I'll just walk you through very quickly in a moment. Let's now go to Montreal, what the setup in Montreal is. Well, in Montreal, we have a full data center setup. It's, again, Lenovo servers, the ThinkSystems SR630 and 650, as well as a number of container network functions from A10, from Turnium, from Altran, from Kaloom, which runs actually a UPF, and Kaloom also runs the software-defined fabric both here and in Montreal. And the Lenovo Open Cloud software that is actually used for managing the entire system from a hardware perspective. So that's also running in Montreal. Now, a lot of people ask questions about, okay, so what was the full software stack? Can you actually show what that software stack looked like? Well, one of the interesting things we ran into was the number of community projects that were involved in this setup, as well as the amount of software that came from all of our partners and different vendors. So if you take a look at the left-hand side of that slide, all of those different community projects and products were involved in this particular setup. On a private cloud environment, both on OpenStack as well as on bare metal, we're running, of course, Linux software from Red Hat, and we're running the Kubernetes platform, OpenShift from there, and then a whole bunch of container network functions, or CNFs. Of course, Intel is also providing a whole bunch of software, Altran, Lutza, so many partners to be involved in this. Now let's take a look at a quick animation of how things work first, and then we'll actually show you all the screens, and we'll actually show you hopefully a live call. Again, we've been having a number of challenges associated with this because we are trying to connect private cloud, public cloud, remote POP, all together over the internet with a whole bunch of tunnels, and I'm crossing my fingers, hopefully everything's going to work. So let's take first. So what happens first is the two phones, the first phone here that's on the stage here that you can see, I'm just going to quickly walk you through. Here's your rack. That's the fabric that you see inside, that's with blue lights, software-defined fabric. Here's the millimeter wave radio, the 5G radio, and that's the Faraday cage. And that's the phone inside there that's actually 5G. So the two phones register. So that phone registers to the 5G core and the LTE core that's actually sitting in Montreal. So it's actually from here, going through that radio, going through that POP, and all the way into Montreal. So that's what you see by the yellow line. The other phone that's in France is registered to its local core right there. Now, obviously, since there are two different mobile networks here, and we don't have any roaming capability, we don't have any network-to-network connectivity like that, so we had to actually figure out a way to show you a live call across those two networks. So we actually decided to host an IMS capability in the public cloud. And what you see in the public cloud there is the IMS core right in the middle. And once these phones attach and have data connectivity, they connect to the IMS core and they actually exchange information. They do the IMS signaling and say, okay, now I can actually do an IMS call all the way across. So when that happens, now you can have actually a call all the way across. Obviously, we've been having some connectivity challenges, so we'll try to attempt a live call right here in front of you. We also have some other people on standby in Montreal and locally, so we'll show you whatever that's possible. So back, please. Let's now go to the screens. Now, one interesting thing that I wanted to show you was the project that we are seeing here is the Altran 5G core project. Within the Altran 5G core project, these are all the different containers that are running as part of the Altran 5G core in the Montreal POP. We also happen to have in the Montreal POP a LTE core. So I'll just show you that as well. So Altran EPC. And you can see that there are a whole bunch of pods that are running as part of the Altran EPC in the Montreal POP. Now, what I'm going to do is also just show you very quickly this setup here, the 5G POP here, and the number of containers that are running here. About 215 containers, or 215 pods on this setup. And you can also see different workloads here. This is default. Let me just go check. Here you go. This is the A10 setup. And I can scroll through any of those different projects to show you the different pods that are running there. So this is all live. Now what I'm going to do is quickly show you first on this phone. If they can zoom in onto the phone, please. I want to go back. Right here, you can see right on top something that says 5G UWB. It doesn't say LTE, it doesn't say 4G, it doesn't say Wi-Fi is on, it says 5G UWB. That stands for 5G ultra-wide broadband. So that's to show that that phone in that cage is actually attached to the 5G network. All right. There you go. There's a call that came in. Let me just accept that call. I got the call accepted. Let's start the video feed. Yay. So that video you can see is coming from the Faraday cage. And we have, hello, how are you?
Hello, Hanan.
I hope you can hear us. And that's a live video feed over there. Excellent. We can hear something back. We can hear some audio back. All right. Okay, thank you so much, Hanan. That was wonderful.
All right, but just let's pause for a moment. That was a live 5G call connecting across public and private clouds, connecting to a packet core in Montreal, an IMS core in the public cloud, and an LTE lab in France. So, good job, Hanan. All right, so as we were building this, we did learn some lessons and we did find some gaps. Zara, do you want to talk about some of those technical gaps?
Sure. I mean, we've learned a lot of lessons. It was really a lot of hard work by a very large team, and I'm actually literally just representing them here. Telecom infrastructure is all about networking. It's all about connecting those different pods together. It's all about connecting those different services together. That was one of the biggest challenges.
Okay.